We're pleased to have joining us today with us to Dr. Eberhard Bluemel, who is head of the Fraunhofer Office and Institute for Factory Operation Automation. He holds a PhD in Natural Science from the University of Magdeburg. Dr. Bluemel has been working for the Fraunhofer Gesellschaft, which is the largest organization for applied research in Europe since 1992. His research fields include virtual reality and simulation, operation research, and logistics. He has many years of experience in the development and coordination of numerous natural international projects focused on technology transfer based on digital engineering. Dr. Bluemel was the coordinator of the project BDTC ProDyma, development of innovative products and service using virtual reality technologies for mechanical and plant engineering SMA. The project has been given a European Regional Innovative Action Award for helping business through the transfer of knowledge and technological innovation in 2004. He was awarded the honorary doctorate of the Riga Technical University in Latvia. Dr. Bluemel will now deliver the following speech: Global Challenges and Innovative Technologies Geared Toward New Markets, Prospects for Virtual and Augmented Reality. Ladies and gentlemen, please give an applause to Dr. Eberhard Bluemel.
Thank you very much for this nice introduction, and thank you very much to the possibility to have the keynote speech at the closing ceremony of the conference. It is a great honor for me. Thank you, George, and thank you, Egils. And yeah, it is also very interesting to have met many experts from several parts of the world here together in the VARE 2013 conference. I enjoyed this very much to learn about new technology approaches for especially augmented reality and also virtual reality technologies for education and training here in this conference. And my presentation will have a focus not so much on the basic research for technologies, but more for applied research. And I have chosen the following outline, give a short introduction about the Fraunhofer Institute, and then we will consider together some global trends, social challenges, and new markets, maybe also for virtual and augmented reality. And then I would like to try to show you some of our projects which are focused on markets which are demanded by the societal challenges based on also global trends which we had recognized. And then conclusion and outlook. Yeah, I'm with the Fraunhofer Institute for Factory Operation and Automation. As I already mentioned, the Fraunhofer Gesellschaft in Germany is responsible for applied research. That means we are a bridge between the basic research and the application in different industrial areas. And for this, the Fraunhofer Gesellschaft operates 66 institutes and independent research units in Germany. We have 22,000 employees and a yearly revenue of about 1.9 billion euros. And our financial model of the Fraunhofer Gesellschaft requires that we have to acquire about 1.3 billion euros each year. from the private market on the one hand side and on the participation on grant research programs by German government or also European Commission. And for operating these researches, we have 7 research groups and clusters focused on the main research areas: information and communication technology, life science, microelectronics, light and surfaces, materials and components, and defense and security. Our institute, which is located in Magdeburg, in the middle between Berlin and Hanover, and we are belonging to the group of production. And that's why I also would like to focus this presentation to the to the production area. So we are also active in international regions. The Fraunhofer Gesellschaft has 15 research units abroad, and our institute has 1 regional office in Bangkok, Thailand. We already had a good conversation with our Thai participants here at the conference. And the aim why we are going to abroad destinations is to cooperate with excellent partners on the one hand side, and also to acquire knowledge from these markets to support our customers in these regions, as well as also our German customers. So the Fraunhofer IFF, I have to say that each of the Fraunhofer institutes are working as a profit center. That means we are not independent in legally areas, but we are independent in doing our applied research, but with strategic guidelines. And so we have the main focus areas in the logistics. That means everything which is in combination with supply chains and supply chain networks from or inside the factories, and also for distribution and so on. Then automation is the next area in which we are focused on robotics, and especially mobile autonomous robots which are doing services. Process and plant engineering is focused on the renewable energy and also electromobility projects, and these 3 areas are widespread in different applications, and they are being supported by digital engineering. This is an area which is focused on virtual product development, virtual factories development, and also education and training. And it is an horizontal technological area which gives support also to the other research areas. And from our understanding of digital engineering, digital engineering and universal use of digital methods and tools over the product development and production process, and it is aimed to improve planning quality as well as the process control over the whole product life cycle. And this means that also education and training will be one important part of digital engineering. And challenges are for also basic research are the physical correct transformation of all problem-relevant characteristics, also including software technical qualities like embedded systems and so on, and the interoperability between the used tools with respect to technical interoperability, semantical interoperability, and also organizational, because we have to take care also for these applications and the application processes that these application can also be introduced into the company processes. And last but not least, we are also focusing on so-called interactive experience rooms to the inclusion of the humans into the digital chain of these processes. It means that they are also can interact, make decisions, get informations, and also bring informations back and their experiences also in a digital form. We had yesterday a presentation of my colleague Tina Hase. She has a paper about how to acquire the knowledge from experts and what is the possibility to bring it in such digital forms for usage. So, global trends. What everybody knows, the ongoing trends, which also focus on the requirements for innovative technologies. We have to recognize an increasing energy consumption over the world by limited resources. On the one hand side, we have also to see, especially in Asia, the growth of megacities. With this, the requirements for new solutions for the mobility is necessary. Also, questions comes from another trend, the demographic development. That means the population, especially in the European area here, become elder and elder, and this has consequences as well in the manufacturing production area as in the social life of the populations. And Fraunhofer started in 2004 a strategic process with the aim to initiate a change from the technology push to the demand-driven solutions and for the cooperation with our customers. And this process has finished in 2011. That means over 7 years, and it will be started now again for the next period. And this process is a structured process for identifying the future topics, and it has 3 stages based on the analysis of foresight studies and also of interviews with experts and with interviews with all the 66 institutes of Fraunhofer. And so in these 3 steps, they started first with perspectives for future markets, then the identification of the Fraunhofer future topics, and then to consider by overlaying these perspectives and our expertise also to define future markets. And in the end of this process, we deliver 5 focal areas for future markets. These are, on the one hand side, health and nutrition, safety and security, mobility and transportation, energy and living, production and environment, and as an also technological oriented area, information and communication technology. I put this out here inside because of it is relevant also for our conference. And the interesting thing is this is not only an Fraunhofer internal strategy to go to these markets, but it is also included in the German high-tech strategy. And this means the German government also focuses on these challenges and these new markets with their research funding programs on the one hand side, and when you look at the European research framework, Horizon 2020, you find one pillar which is focused on the societal challenges, and you also find these 5 areas which I mentioned in the work programs which will start in the next year, which is very important also for the collaboration with other partners. That's why I also mentioned this. And this strategy also will be break down to the institutes. Each of the institute of Fraunhofer has such technology audits which are market-oriented, and we also have to look in which areas we can support these strategies. And here I put out this production and environment area, and here we say, for instance, production that saves energy and raw materials. That means resource-efficient production, resource-efficient production development, whatever this means, and also new production processes, and last but not least, also digital engineering as an enabling technology for supporting these approaches. And especially also Fraunhofer target areas in the information and communication field are the image processing, for instance, broadband communication, cloud computing, and grid computing. And here also what we are doing, considering here e-learning, edutainment, and games. Here in this VARE conference, we have, I did not count it, but more than 50% of presentations focused to this area, and also using virtual and augmented reality. And, but most of these technologies have been focused on specific solutions, on technologies, and that's why we also, this is also when we started with virtual reality applications, this was in 1996, then we started to develop our own virtual reality system, own technologies, and we have also been supported technology push, but now we think in processes, and the question is how we can use our experience and experiences with our partners, and we are also close connected with other research institutes as well as with universities, and then also to find and to cooperations, for instance, for these markets, as I hope, in this area: production and environment, energy and living, mobility and transportation, safety and security. And here in the next steps, I will show some examples of not products, but projects we did. For instance, towards resource-efficient production, resource-efficient production and logistics, and also for assistance for workers, infrastructures for renewable energy systems and smart grids, electrical vehicle networks and smart grids, and smart logistics zones. Here I do not have an example for education and training because of Tina Hase already introduced these, and I had also a speech in the VARE 2011 about these, and so also due to time restrictions, I would like to focus only on these 4 examples which I showed to you. So when we speak about the resource-efficient production and resource-efficient product development, we have also to think about what support can be given by virtual reality or augmented reality for these processes. And together with some of our industrial partners, we worked together on a project which we call Review 3D. This is a virtual reality based tool for supporting functional design reviews and digital mock-ups of factory and plants. And this is focused to support the planning, development, training, marketing, and also supporting public relations for our customers. And when the technology behind this Review 3D tool is to use the virtual reality as a communication platform between the different experts which are involved in these processes, as here mentioned, planning and so on. And these experts are using their own tools, their own simulators. We have simulators for material flow, which are discrete simulators. We have simulators for robots in these processes, which are supporting decisions about the kinematics, and humans for ergonomical things and so on. And the idea behind the Review 3D is to bring together the visualization of the results of these different simulators and different tools in one virtual reality-based visualization platform. And so we would support by these animations the demand-driven design reviews. That means that everybody of the experts has the same view on the results, and they are able also to discuss with their colleagues changes and future developments. So now I would like to try to go to a video. This is not with audio. So in this video, we have an example of the collaboration with John Deere in Atomba in Iowa State, and for a new assembly factory for tractors. And here in this, I hope you can see it, the light is a little bit. And here in this visualization, we embedded results from the material flow simulation and from the process description and process model of assembly. This is not a cartoon here, but it is a real-time simulation about the whole process of assembly of these agricultural vehicles. And here this guy is waiting, and this is a fast motion. You see, it is 166 times faster than the real process. And this animation is driven by the results of the simulation and as well as by the process plan for the assembly at different stations. And another challenge also was to bring together an holistic data model, bring together also the details which are necessary, and also have the possibility to interact with this visualization. Here in this video only is shown the process of this full assembly, and also it was a big challenge to handle this big data from the process, because of we used here the original data from John Deere. Oh, first I have to close this. Yeah. So it's yeah, I already explained this example. Another example which is focused also to the production and environment area. Here in this case, we have to consider the problem of repository for nuclear waste. Nuclear waste is a result of the production of electricity, and normally it will be reposited in salt dome, and the question is how safe is such a repository. And normally the experts are doing experiments in real mining areas, but for these salt domes there does not exist real laboratories for doing experiments. And the interesting thing is here that the simulation for the long-term deposit of this waste have to consider thermal, hydraulic, and mechanical processes, and this is the same thing as we had here in the factory. The simulation will be external by different tools, and each of the partner worked in the past separate with these tools, and also with the geological model, as well as with the mining structure of this salt dome. And our solution is here to develop a virtual repository in which all these components come together. This means I will here also start a video for saving a little bit time. We should go ahead. Here you see the geological model, 3D model of a salt dome, and here in the colors inside we now dive in the virtual model. These different colors shows drifts in this virtual salt dome. It shows typical celebrado series. That means different kind of geological materials which are important for the decision making about the mining structure which should go in. And here you see the mining construction. This is integrated in the geological model, and the challenge for the technology was that these data model and this integration of these different parts bring a new model which is valid for developing finite element meshes. And these fine FEM meshes will used by these simulators for the thermic, hydraulic, and also mechanical development. And so this is a tool for planning experiments and also for the visualization of the results of the experiments. Here inside the mining structure you see the, now I forgot the right name, the containers of the nuclear waste. And here you see results of the thermic simulation over a long time. I guess here this was a period about 10 years, but the experts are going up to 100 years, and to show what are the development of these three different processes. And what they did, they gave us their requirements for the design of the results, which forms we should use, which colors, and so on. It should fit to their processes, and that's why here we have very different possibilities to show in which way the results of the simulation are to be interpreted. And one interesting thing here in this project is that this tool is used for scientific purposes as well as for the communication with the public society, because of this is a very sensible theme, the nuclear waste deposit, and the information about this is very important. So another problem is for the production is the demographic change. We have the situation in Germany that in 2020 more than 40% of the workers will be in an age above 50 years. And this means they need assistance, maybe physical assistance as well as virtual assistance or communication assistance for doing their job. And here in this project, visual assistance, we use augmented reality technologies for a visual assistance system for the assembly in a machinery company. And the benefit is that complex procedures become manageable. We also have completeness checks and so on. I will explain this also during a video. Unfortunately, it is in German with text, but also with speech. Here you see the assembly process with the worker, and you see here the camera systems, 3D cameras, which produce pictures from the assembly. And here you see at the monitors, touchscreen monitors, the virtual models which shows the position of the actual assembly stage. And here in the engineering department, the construction of the tools are done, as well as their use or their preparation for the augmented reality models. And in these red lines, you see the positioning, and in real time, the worker gets the information, is the position right or not. And if he is complete with one step, he uses the touchscreen and gets the information for the next step. Also, and when he needs, here you see these camera systems, here you see the row with the monitors, and then his real working place. And when he needs support, then he can use this, here you see this touchscreen, can see the part which is to assemble and get the information about this. And here you see these are also very huge parts. And the director of this assembly line told us that they reduced the failure and by 25%. And this is not only a contribution also to assist and make the work easier for the elderly people, but also to increase the quality. And this is also something which helps for resource efficient production. If you have failure, you have to rework and so on. So I spared now this slide. We have seen it in reality. So the next project which I would like to introduce, the time is running, I see, is focused to the interactive infrastructure planning. We have seen here a lot of presentations also using virtual reality or augmented reality for this area. Here in this case we speak about infrastructure planning, and this means for the energy change which was decided by the German government, we focus on the increase of use of renewable energy, windcraft, solar industry, and so on. And we have the problem in Germany that especially the windcraft energy will produce product in the north of Germany, and the consumption will be in the south of Germany. And there are forecasts that say that we have to install more than 200,000 kilometers of transmission lines for the electricity through whole Germany. And this brings not only the technology, economic efforts, but also problems for the acceptance by the inhabitants and by the stakeholders which are influenced by these work. And several years ago, we already started projects together with Vattenfall. This is a company for energy supply in Germany, and they had problems, especially in the area of Berlin, to get acceptance by their by the stakeholders around this area. And so we started with them a project which enables a simulation or enables a design for the planning of the electrical transmission lines. We support the development by different tools which you see here, especially, for instance, the electrical tower are in different variants available and could be used for an interactive planning based on a real model of the real landscape, which has been done by area. Oh, something is wrong with my computer. It's not so fast. And here you see the development of the line. You can make corridors. You can also calculate areas of visibility of this line, and so you recognize here is a direct influence of maybe inhabitants which are living there. In the green area there's no problem. These are visibility analysis here which can be done, and the possibility is also to go to different viewpoints. In the case of Berlin, we have also the possibility to go into the houses, into the apartments, and show the people that they are not influencing. If it is so, then we have also the possibility to simulate what will be possible, maybe by trees or other green areas which could be planted, and you see what will be the view in few years. And this tool is being used also to get inputs from the stakeholder. The idea of Vattenfall is not to go in confrontation, but also to learn about this. And this is applied several times, very successful. So, can I use 5 minutes? So, another project.
Sun, water, and above all wind. Renewable resources are already strongly shaping power generation in the Harz and Magdeburg.
Another project is also connected with renewable energies, but also with electromobility. And before I start the video, I would like to go to the slides. Here in this project, we had made a test bed for innovative mobility by electro cars. About 50 electro cars have been involved, real one and additional virtual one for testing different routes between Magdeburg and the Harz Mountains, which are away of 100 kilometers from Magdeburg, with different profiles of streets and so on. And they should be supported for their getting energy from the, not petrol station, but for the electrical stations by a control center, which not only has to support the drivers, but also to control the electrical grid and to avoid that there are instabilities by the not so continuous, not so stable electrical networks when renewable energy is used because of the weather conditions and so on. So, and this video will explain. I hope it works.
Sun, water,
Yes.
and above all wind. Renewable resources are already strongly shaping power generation in the Harz and Magdeburg regions. How can we optimally combine the integration of renewable energies in the grid with electromobility? This is being researched in the project Harz EE Mobility, a consortium of universities, research institutes, and large and medium-sized enterprises, is exploring anticipated changes in the energy, communication, and logistics infrastructure, and developing new concepts and solutions. First, the driver's perspective. Electric cars have a rather limited range of less than 150 kilometers. This limitation and long charging times are perceived impediments. How can we make the most of these vehicles in everyday driving then? To begin with, the electric vehicle status information is transmitted to a mobility control center. The software in the mobility control center uses the information and data from the traffic guidance system to project the movement patterns of all electric vehicles and their distributed energy requirements. The Energy Control Center delivers information on the amount of renewable energy being generated at the moment and the storage capacity available in the electric vehicles. All this information and these basic parameters are optimally coordinated for our vehicle to utilize a maximum of renewable energy. The software in the Mobility Control Center then uses the data from this optimization to identify the optimally located charging station and communicates this to the driver through the driver information system. This information is then used to optimize the proposed route. Quick, clean, and convenient. Smart combinations of the logistics infrastructure, communication systems, energy management systems, and privately driven electric cars ensure that everything fits together optimally. Renewable energy, grid management, and electromobility, optimally integrated in the Harz region in the future.
And I think especially here it has been illustrated that the virtual and especially maybe also augmented reality technologies can go to support these information systems because of the high complexity, especially for the operator in the control center, is very high of information, and this is still a research area in which we are also working. So I will come back to come to the conclusion. I think we have seen the societal challenges like production and environment, energy, mobility, and so on, has opening prospects for the development of new technologies, services, and products for the use in future market. Digital engineering is going to enable the seamless integration of virtual and augmented reality platforms in real working processes and vice versa. I think there are a lot of possibilities also for new solutions, and from our point of view, it is also necessary to provide widespread usage of virtual and augmented reality technologies for training and education, especially in these new technology areas. And we work to enhance the technologies to provide a basis for the knowledge transfer and innovation networks in incorporating partners from society, universities, and also other research institutes. And last but not least, the industry, because of they also should bring in their ideas, their demands. And one of the instruments which in Germany, the landscape is very successful, are so-called innovation networks or innovation clusters for the collaboration of universities which are doing basic research, education of students, which should assure also a sustainability of new technologies. Applied research organizations like Fraunhofer and the industry for product and service development. And so we are interested also to collaborate to use the virtual, the digital engineering to close this circle from the development or from the research, development, and education and training for the future. And here, within Fraunhofer, at these days, we work on renewable energy networks and also to push for future developments. So, and as an outlook, I will show another video which is focused to the so-called Morgenstadt in German language, or city insights or city of the future. And this is a so-called lighthouse project funded by the German government, which is an experiment to bring together all these new markets in one town, and which I already showed. And so I will finish.
There are lots of ideas about what cities will look like in the future. But what are the inventions that save energy, that make our everyday lives more pleasant, our air cleaner, our rubbish less, our cities more green and safer, and our traffic less congested? What if every house were a mini power station, producing and storing energy and sharing it with others? Facades were multifunctional and could clean the air. People were to network with one another and with the city and reach decisions together. Products and goods were produced in cities to reduce transport and commuting. Green spaces were to be created on roofs. Traffic were emission-free and shared. What would it be like if our cities were quieter, more sustainable, and more adaptable, and we were to move into a new urban era with innovative solutions and technologies? What does the city look like which you want to live in the future? In the city of tomorrow, ideas come true.
Sorry for the quality.
Fraunhofer, on behalf of the future.
Maybe it's too late for, for this. Yeah, then thank you, and yeah, welcome to Fraunhofer IFF, maybe for collaborations.
Thank you.